Hello all, welcome to my channel. In this blog, we will be discussing few alternatives of Flink. This is an ongoing series of open source alternative to common established what you call aspects of data platform. In last video, we discussed a few of the options that we have when it comes to having an alternative for Spark, like Data Fusion, DAST, DAFT, DuckDB. So those were the things that we discussed in last video. In this video, we will be looking at few alternatives that we can use to process event data in a streaming fashion. So let's get started. So as we know, Flink is a real-time streaming framework which is built to process data in real time. It can consume from different sources and then write to different sinks in while processing the data in real time. But to maintain a Flink system is challenging because it requires state management, plus it has a lot of moving components like uh, it's a distributed and it has concept of worker nodes, task slot, and stuff like that. So it's not that straightforward to host and Flink cluster. There are many managed services. For example, Verberica offers managed Flink. Then Confluent also is offering Flink in their platform. AWS offers MSF, which is a managed streaming application for Flink. So there are options which does take away the intricacies or the complexity involved in hosting that platform or hosting that distributed cluster for Flink. Uh, but still, it is difficult to operate Flink at large scale. One being the state management is very difficult, and the other one is Flink in general. This is my feeling that Flink in general is not that much of transparent system. It's a box kind of system where you have source and you have sink, and in between what is happening is generally not that transparent. For example, till few times back, there was no way for us to directly query the Flink state itself. Now it is available, like we can query Flink state as a data frame itself, but earlier it doesn't used to be the case. And hence there were a lot of other tools that came up to support Flink's observability. For example, there is a company called Drift.dev, which is trying to make Flink observability a better solution. Then there is another service. I think its name is Datoris, which offers Flink observability as well. So yes, there are some tools, there are some new systems coming up to support that, but from an alternative point of view, why we are talking about this is that not all use cases require a full-blown cluster for us in case we have to process some events in real time. If we have use cases, then yes, definitely Flink is a better solution, but why not use what you call tools for certain scenarios rather than treating everything with a big tool. Why not? We call it purpose-built tools. So if we have use cases and that can be solved using these systems, there is no need for us to have Flink. So let's get started. Let's see few of the alternatives that are there. The first one that we will talk about is Quix. So Quix is an open source Python package which we can use to consume from streaming systems and then write it back to another streaming system or whatever wherever we want to persist that data into. Uh, Quick Streams is a Python framework, so it is well integrated with Python libraries. We can directly use the library. For example, we can directly use LAMP pandas to do the transformation, and it still will work in real time. How it works in other scenarios. So yes, this and the structure wise, for example, we have a data source from where the Quix is reads the data or writes it to, and then it will process and analyze and then creates the insights in wherever we want to push that. So it can write it into, let's say, Elasticsearch, Kinesis, Kafka, RabbitMQ, DynamoDB, or anywhere, or even it can push notification directly to mobile devices as well. So not directly, there is an interface in between, but yes, that option is there. And as I mentioned, it's a Python binary. It can be installed. Uh, we can do Python pip install on the quick streams, and then use we can use this. So this is an Apache project, and I mean, license-wise, it is an Apache 2 license. It's not an Apache project per se, but the license-wise, it's an 2.0 license, so we can use, modify, and resell this. There is a company which is behind this, which offers a cloud version of this, and that provides removes the complexity of running this ourselves, and they provide all the connectors and everything in the cloud version itself. Few of the things, like there is no JVM involved in his this is there is no separate cluster that is needed. This does the stateful operations using RocksDB, can be resiliently scaled on Kubernetes platform, and it has a declarative configuration with app.yaml and quix.yaml as a pipeline. So those things are something we can look at. There is a there it's their documentation is very good. Like we can see how we can consume from Kafka and write to Kafka. There are certain templates already there on their GitHub repo as well. So uh, just give it a try. It's a good project to work on. Now we have another project called Bytewax. So Bytewax is, again, it's an open source Python framework for building highly scalable data flows in streaming or batch context. It is based on the timely data flow library, and it is written in Rust. So this is slightly higher performant than Quix. So see, whenever I say high performance, it doesn't mean that one is better than other. They all have their use cases in different scenario. They excel at different things. Uh, so yeah, but overall, Bytewax is again, it's also open source, and we can reuse it. It can it can be deployed on Kubernetes clusters. It has a Helm chart that we can simply use and configure to run on any systems. It has also concept of connectors, like which systems it can read and write to. So that's another alternative in here, which is called Bytewax. Then we have Pathway. So again, Pathway is something similar to what Bytewax does. It is written in Rust, and it is built on the differential data flow that is there, and it processes incremental data. Again, this can read from Kafka, write to Kafka. This can read from NAT server and write back to the NAT server. And their NAT's use case is very good and well documented. So this use case of processing a fleet of telemetry data using pathway processor is a use case which was done at a large company. So this is something which we can take a look at as well. Then we have Fluvio. So Fluvio is another um, open source streaming platform which is written in Rust. So you will see this trend going on, that a lot of streaming systems are getting rewritten, or newer systems are written in Rust. And so this uses Rust and WebAssembly. So WebAssembly is another framework which helps us in running, which is kind of an lightweight alternative to containers. So that's what we can think of it as. Again, here we have concept of streaming processing unit and streaming controller, and based on that, the controller decides, okay, how many SPUs is needed, and they allocate that slot. The function is sent in there, and then it processes and then returns back the response. So yeah, this is again some one thing which is good to know. It has a Fluvio CLI. Using that, we can deploy on Kubernetes, or we can use again Helm chart, which is there on the open source GitHub library itself. We can use that and then process streaming data using Fluvio. Uh, then we have Kafka Connect. So Kafka Connect is a framework which is written in Java, and it allows us to consume and produce to and from Kafka. So that's what this Kafka Connect framework is built for. So it like the concept is that you create a plugin for a particular source. For example, let's say we want to consume data from a database, so we have that database connector so the connector, it takes care of like batching, producing the records in batches, buffering, uh, consumer group allocation, producer configurations, and all those things is taken care by the framework, and we just take care of the business logic of how to, what to move, when to move, and that stuff like that. Similarly, the consumer will have, or sync will have uh, assist consumer sorry that connect sync will have the same things like batching, consumer group assignment, consumer group leader being elected. So those kind of things is taken care by the framework, and we just have to implement the logic which is required to talk to the target system or to process the system. So that's when this Kafka connect comes very interestingly available to us. For example, in AWS MSK, we have option of Kafka Connect that we can use to move data from, let's say, Kafka topic to S3. So that option is there, and it is being used in production. So in Visa, we had a case where we wanted to offload the Kafka's topic data for audit and compliance purposes. So we built a Kafka. So we already have offering from Kafka Connect. So we just use that Kafka Connect to create to run a connector which comes in serverless way. AWS manages the underlying uh, node provisioning, and then connect runs on a schedule and then offloads the data to S3 object storage. So there also we have one is for the source, another one is for the sink. One reads from the Kafka and then writes it to S3. Then we have Kafka Stream. So Kafka Stream is a client library provided by Kafka for additional stream processing and transformations. And this is only on top of Kafka itself. It does not interact with any other system, and the input and output data are stored in Kafka topics. So, and this combines of writing and deploying standard Java and Scala application on the client side with the benefit of Kafka server side cluster. So the thing is, what is happening is when you process in the write something to a Kafka topic, and if you want to do certain processing before that gets consumed, this design using Kafka streams is something which comes handy and can be lightweight, and we won't be needing a different cluster that needs to be set up for this. It uses the same Kafka cluster to do the processing as well. So yeah, it is a good option if we are only bothered about Kafka ecosystem. There is no other external integration needed. Kafka Streams is good. So the difference between Kafka Connect and Kafka Stream is that Kafka Connect focuses on moving data in and out of Kafka. That's what we were doing. We will have source connectors, we will have sync connectors. In case of Kafka Streams, it operates on data within the Kafka. So this, if you see, this is the diagram from a system point of view. So we have the source. Kafka Connect will pull data from data source and write it to Kafka, while the Kafka stream will read it from Kafka and write it back to Kafka itself, doing some transformation. And then we will have Kafka Connect sync source, which will read from Kafka and write it to a data sync. So if you see, connect is to move data out in and out of Kafka system. Like this source is moving in the data, while the Kafka Connect sync is moving out the data from Kafka cluster. But the see Kafka streams, it is something which is running inside the Kafka cluster itself. Uh, then we have KSQL which is nothing but a SQL interface on stream processing engine built on top of Kafka. This also is something real-time processing that we can do using the SQL interface. Well, this is sorry. This combines the stream processing with SQL approach. The only downside of this is that this is not directly available in the Kafka API. This is wrapper on top of Kafka streams that we can use at. Then we have Spark structured streaming. The structured streaming is an Spark concept where it says it creates mini batches and then processes that micro batches and then processes that to make the system look like it is a real-time system, but it is not real-time, it is near real-time. So this is also a good approach, a good option, alternative to Flink. The reason we do consider this because a lot of companies do already have Spark in a cluster running for their batch workloads. So the same cluster can be repurposed to use for streaming use cases as well. There are certain limitations that is micro batch architecture, and it doesn't have it has only limited stateful processing. It is not slightly complex to operate. Slightly some performance overhead is also there, and latency numbers are higher compared to what Flink provides. Then we have Bento. So Bento was actually initially it was a project called Benthos, which was a Go-based project for real-time data processing from these systems like event systems like Red Panda or Kafka or other systems. But later on, it was acquired by, I think Bento was acquired by, sorry, Benthos was acquired by Red Panda, and at that time, the creators of Benthos decided to create a fork, named it Bento, and this is now available as an separate project itself. It also has a concept of source and sinks, similar to what other engines have, and it is written in Go. And it is performance is very high, like it is battle tested in production systems as well. And only thing it does not have a full support for the stateful transformation like Windows and joining or aggregations. But if we only have to do event processing, Bento can still be a good use case. So these were some of the alternatives to Flink that we can think of. There are some caveats that will like to be highlighted is that all the solutions that were discussed doesn't have full stateful transformations like Flink does, because Flink's only purpose was to do that. It has a lot of transformation and stateful transformation that it has. And at large scale, like if you are trying to process data in, let's say, petabyte or terabyte range, Flink will generally outshine most of these solutions. But again, with those features, it has the added complexity of maintaining and running a Flink cluster. There are some other notable ones mentions that we can use. Benthos, as I mentioned, was acquired by Red Panda. Glassflow is another engine. So the reason I have not included these directly is that they are not only trying to compete with what you called one particular system. Like they are not only replacing Flink, some of them replaces Flink plus Kafka altogether. For example, Fluvio also does that. Fluvio is also something which is an combination of Kafka plus Flink, but in general, uh, that was the closest that I can think of. But this Fast and Glassflow, they are not only stream processing, but they are in streaming platform itself. So Glassflow allows us to do the processing as well as the acquisition of the data, something similar to what Kafka does. So yes, these two are also another options, and both of these are not, I believe, open source. They are managed solutions which are there. And cloud specific solutions are also there, like Apache Beam in GCP, and Kinesis is another solution which is in AWS, where you can do certain transformation on event data that gets ingested into the system. So yeah, this was one quick short video. So in a summary, we have options like these are the options like Pathway, Structured Streaming, Quix, Kafka Connect, Fluvio, Bytewax, Bento, Kafka Streams, and KSQL are some of the options where if you want to process streaming data without much of the what you call windowing or a window based or stateful aggregations, these systems will be good enough for us. So give them a try out, and what you call, we always should be looking at systems which can solve a problem at hand rather than thinking in terms of tool. Let's think of in terms of solutions of building a better data platform. That's it for this video. Have a nice day. If you like this video, do share and spread the word. Bye bye.